So as you can see, we have two particles, particle P and Q. The masses are given. Mass is 5, so weight for P is 5g, and for this one it will be like 10g. So since they are connected by a string, so there will be tension. So if I like take free body diagram for both of them individually, for Q, tension will be vertically upward, and for this one, tension will be in this direction, as in tension acts always away from the body. So for P, since P will move in this direction along the plane, so that's why this is the new x-axis, and perpendicular to this is the new y-axis. So this alpha, this angle, you can shift it here. So as you can see, we need to break down the components of weight, and it's already given that tan alpha is 0.75, so we have to use that information. Coefficient of friction is 0.2. The system is released from rest, so it's obvious if you release this thing. Okay, so the direction is not clear here, like it can go down and P might move up, or it can also be the other way around. So since direction is not mentioned, you can take either direction as positive. So since its weight is 10g compared to that, so Q will move downward and P will move upward. So I'm taking downward positive for Q, so the equation will be like 10g minus tension equals to ma, so 10a. So from this you get the first equation, 10g minus 10a. So that's for particle Q. And for P, you need to include all the forces. So let me just simply break down the component for weight. So we have one of the forces here, which will be like, since it's adjacent to the angle, so it will be 5g cos alpha, and this one will be 5g sin alpha. And since there is friction, if it goes up the plane, friction will be down the plane. So we have frictional force, which is mu r. Mu is 0.2, but r is unknown. R is, we need to calculate r. So r acts perpendicular to the plane. So I have already included all the forces. So if I like start writing the equation for P, so tension is positive, friction is mu r, and you need to include this one too, like the weight is actually resisting its motion, so weight is down the plane, so minus 5g sin alpha equals ma. Mass is 5, a is unknown. So in this equation you can substitute the value of mu is 0.2, but r, as you can see, there won't be any movement in this y direction, right? So it's balanced, so r equals to 5g cos alpha. So r equals 5g cos alpha. We do not know the value of cos alpha. You need to solve this triangle. If that's alpha, 0.75 is basically 3/4. So it's given that tan alpha is 3/4. So it means 3 is the opposite side and 4 is the adjacent one. So hypotenuse is 5. So from here you can see that cos is adjacent by hypotenuse, right? So cos will be 4/5. So if you cancel out 5, you get 4g. And we need the value for sin alpha, which will be opposite by adjacent, so 3/5. So if you cancel out 5, we will get 0.8g minus 3g equals 5a. So from here you will get the second equation, t equals 3.8g plus 5a. So that's your second equation. So if you solve this two equation, like if you just equate them, like this equation equals that, so you will get 10g minus 10a equals this 3.8g plus 5a. So 10 minus 3.8 will give you 6.2 g equals 15a. So it's 4.1. Okay, so a is 4.1. So I'm done with this example math. So you just substitute this value of a in this in any of the equation, you will get the value for tension. So that will be 57. Okay, so as you can see, the main concept is similar to the ones we have already solved, as in you just need to include all the forces, then you need to write two different equations, equation of motion for each of them using the formula F equals to ma. You select the direction of motion as positive, so any forces opposite to that direction will be negative, and then you just solve them to get the value for a and t. So we have two particles p and q of equal mass. Mass is not given, so that's why this is m. Similarly q is also m, so weight is mg, weight is mg. They are connected by a light inextensible string. The string passes over a smooth pulley. Pulley will always be smooth, like we do not include any frictional force here, we neglect the frictional force. So the pulley is fixed at the top of this smooth inclined plane. Okay, so this is even easier than the one I have just solved. In my example math, I included a rough inclined plane, so that's why we had to use this one, mu r, the frictional force. We had to work with the frictional force, so because of that frictional force I had to calculate r. So this number 6 is even easier than that, so we do not need to be concerned with the frictional forces here. The plane is inclined at an angle of alpha, so this is also tan alpha is 0.75, so this is the same thing we have already solved here, right? It's the same thing. Tan alpha is 3/4. Then particle p is held at rest at a distance of 2. Okay, so this time we know the distance between this particle p from the pulley. It's 2 meter. Q hangs freely on the edge of the plane at a distance 3 meter above the ground. So particle q, distance above the this distance is 3. Height of q above the ground level is 3. Okay, then particle p is released. Find the speed with which it hits the pulley. Particle p is released, so when particle p is released, so p will move in this direction, q will move in downward direction, and then p will hit the pulley, because this direction, this distance is 3, right? So by the time q is moving towards ground level, so this distance is 2, which is less than 3. So p, after crossing this distance, when it comes to here, it will hit the pulley. When it covers the distance of 2 meter, it will hit the pulley. So we just need to calculate the speed with which it will hit the pulley, as in since we just released this whole system, so initial velocity is always 0, right? And we need to find the final velocity with which p hits the pulley. Distance between this initial point and the pulley is 2 meter. So we just basically need to find the acceleration. So if you know the value for a, we can use the formula v square u square 2as, right? So it's almost similar to the last one. After finding acceleration, you just need to find the value for velocity. So that's the extra portion we need to solve. So let me just include the forces here. So this is my imaginary x-axis, that's the y-axis, this angle is alpha, so this is mg cos alpha, and this direction will be mg sin alpha. Okay, so since we do not have any frictional forces, so we do not need to mention mu r, or we do not even need to work with this reaction force r. Okay, so for particle Q, if I just form an equation for Q, F equals ma, so weight is mg, downward is positive, weight is mg and T is negative, equals ma, mass is m, A is unknown. So from here you get the equation of T, mg plus ma, sorry, mg minus ma. Okay, so that's the first equation in terms of m, because we do not know the mass. Then for P, tension will be away from the body, so tension will be in this direction, so T is positive, weight, component of this weight is negative, so sign is opposite by hypotenuse, right? So this is actually 3 by 5 mg. Okay, so 3 by 5 mg, so I am replacing this value here, 3 by 5 mg. So tension minus component of weight equals ma. So from here you get 3 by 5 mg plus ma. So that's my second equation. So if I just equate them, the equations are in terms of A, G and M, all the three letters. Okay, so mg minus ma equals 3 by 5 mg plus ma. So the first thing we can do is we can cancel out all the m, right? You can factorize m from both sides of the equation and cancel it out. So we are left with g minus a, then 3 by 5 g plus a. So if I shift the sides, so you will get 2a equals 1 minus 3 by 5. So 2 by 5g. Okay, so if you cancel out 2 from both sides of the equation, you get 1 by 5 of g, which is approximately 1.96. Okay, so we are not done with this math. Like, we calculated the value for A. Since the question didn't ask for tension, so I'm not substituting the value for A. I will directly move to this portion where we need to calculate the speed with which particle will hit the pulley. So as you can see, Q will move downward, P will move upward. So P will hit this pulley. So we need to calculate this velocity. So U is 0, distance is 2, A is 1.96. So using the formula V square U square 2AS, we can solve this one. So part B, U0, V, we want to calculate the value for B. Distance is 2. So V square U square 2AS. Okay, so if you just calculate this one, you will get the value for V. Which will be 2.77 meter per second. Let's solve number 7. So we have two particles P and Q of equal mass connected by a string. The string passes over a pulley which is fixed. One face of the wedge is smooth and inclined to the horizontal at an angle of 30. So the diagram can be given, or sometimes you need to draw the diagram. For example, in this one, so suppose this is the horizontal level, so the smooth wedge is at an angle of 30. So let's assume this is 30, and then the other face of the wedge is rough and inclined to the horizontal at an angle of 60. Okay, so this is how it should look like. You do not need to draw an accurate diagram. You just draw an approximate 30 degree and 60 degree. Okay, so this is a situation, and it's already mentioned that this wedge, which is at an angle of 30 degrees, smooth. So we do not need to calculate any frictional force for this one, but the other face is actually rough, so you just draw hatches here so that you remember while solving that you need to include the frictional forces. Okay, so the particles are, particle P lies on the rough surface. Okay, so here we have to include particle P. Okay, so suppose this is particle P and mass is what? Mass is M. Mass is M. We are assuming that mass is M, so weight is mg. Particle Q lies on the smooth face. Okay, so we have to take particle Q here, so that's particle Q, so weight is mg. The coefficient of friction between P and the rough face is 0.5. So for this surface, since we have to include the frictional force, so mu is already given 0.5. So I guess you guys are okay with the diagram. Like, you read the question and insert all the informations on the diagram, and then we can just include all the forces, then solve the equations, form the equation for each of them using the free body diagram, and then we just need to solve them. In today's class, I just included acceleration and tension, acceleration of tension, but in question paper math you will get part C, D, F, in which the string might break, the string will be slack, so there will be moment of inertia, the thing we have already done in other types of pulley math, right? But for the time being, I am just focusing on this one. Besides, the concept is same, moment of inertia, the thing we have already done in the previous lectures. It's similar to this. It's just the difference is just in the arrangement. Okay, just we need to for this one I will just use a different question to calculate the force on the pulley. Okay, I will come back to that later. I'm just writing it just for my reminder. Okay, so let's continue. We just need to find the acceleration and tension. Okay, so for Q, this is my x-axis, that's my new y-axis, so this angle will be 30. So this angle is 30, so we need to include the component of the forces, right? So this will be mg cos 30, and that's mg sin 30. There will be reaction force, but since we were not working with frictional force, it doesn't matter whether you calculate R or not. Okay, so oh, I didn't even draw the pulley. Wait. So there's this pulley, and there's a string that passes over the pulley and connects the two particles. Okay, so this is the situation, and I need to break down the component for this one, particle P. So for P, since we are more habituated with this kind of diagram, right? But sometimes they also include math in this direction, so you just need to remember that whatever your direction is, weight will always act vertically downward, and this angle, the angle between plane and incline and horizontal line, you shift this with you shift this here, as in with the y direction, always with the y direction. Okay, so suppose for this one 30 is directly shifted here. Okay, you're not taking here, right? I have already explained the derivation of this one in the very beginning of the lectures, in which we actually solved practice math for this inclined plane. So this is my x-axis and y-axis. So as you can see, we have the x-axis and y-axis. So this 60 you need to shift here, okay, with the y. So we have a right angle triangle here, so this one will be mg cos 60. It's way too congested here. Okay, wait. So this is mg cos 30 and that's mg sin 30. Mg cos 60 and this will be mg sin 60. And we have a reaction force. Okay, so I'm more or less done with the diagram. I will just form two equations now for particle P and Q. So far, if you guys have any question, you can always ask in the comment section. And I guess it's just that diagram, in most of the cases diagram will be given, but sometimes you just need to read the question and draw it by yourself. Okay, so I will just form equations. Let's start with Q since it's easier. P has frictional force and all, so let's start with Q. Okay, so for Q we have to use this equation F equals ma. We have tension, right? We have tension here for Q, and for P it's in this direction. Okay, so we do not even know in which direction they are moving. Okay, so since they are of same mass, and if it's 30-30, in that case there should be a confusion, or they might stay in equilibrium position or something. But it's clearly obvious that this is steeper. This angle is 60. This is steeper, so this particle will fall and this will rise. Okay, so I guess the direction is clear now. So these particles have same mass, same weight, so it's the angle that is actually determining in which direction they will move. Since this plane is actually besides, it's not actually, we are not even sure. It might be like Q might move downward, P might move upward, because there is frictional force here. So you never know in which direction we are working. So if the direction is not mentioned, you choose one direction and then you just solve. Okay, so let's use this one. Eventually it's just that if you solve, you might get a negative acceleration. That's the worst possible case, but then again you will choose the magnitude, so it will not matter ultimately. Okay, so let's assume that P will move downward and Q will move upward. And since it's students math, students book, so that's why it's so much clumsy and messy. In question paper math, they actually provide you the diagram. In majority of the cases, in 95% of the math, you will get a diagram, and they will also mention about the direction. Like for example, in this one, they will give you a hint about the direction. If not directly, they will indicate you by something like it will P will hit the pulley. It means P will move up. Okay, they might ask that what is the time when Q hits the ground, so that gives you an indication about the diagram. So we will see that when question paper math, there is less confusion about the direction. Okay, so Q is going upwards, so Q tension is positive. Component of weight, this one, mg sin 30. Since we do not have any frictional force, so these are the two forces along the plane that we need to deal with, and sin 30 is half, so tension is half mg plus ma, so that's the first equation. So for the second one, I'm taking this direction as positive. So in this direction we have this weight mg sin 60, and then tension is negative. Since we have frictional forces will obviously act in this direction. So we have frictional force mu r. Mu is 0.5, and r, since the whole situation is balanced in y direction, so that's why if you just equate this two things, r is basically r is mg cos 60. Okay, r is mg cos 60 equals ma. So if I simplify this, wait, so root 3 by 2 mg cos 60 is half, and we already have a half over here, so half into half we have 1 by 4 mg ma. Okay, so T is basically 3 by 2 mg minus 1 by 4 mg minus ma. Okay, so this is the first, these are the two equations. So I will just equate them and solve them. In number 7, we will ignore direction. Now we are not ignoring direction, we are just selecting, assuming that P is moving in this one and Q is moving upward. You just assume and select one direction if nothing is mentioned. If there wasn't any frictional force, then we are very much sure that because of the steepness, P will move downward. Okay, but since there is frictional force, there might be a possibility that Q might move downward or P upward. But then again, I think P will move downward because the angle is way too high, like double the angle of 30, right? So it's way too steeper compared to this plane. So this particle is supposed to go down. But like I said, even if you cannot understand whether it's steeper or not, whether a P will move or in this direction or that, in that case, it's just that after solving the entire thing, you will get a negative value of tension, negative value of acceleration. That will indicate that you selected a wrong direction as positive. But you will get the marks because you will ultimately write the magnitude of these variables. Mass will, in this case we are working with equal masses. I didn't selected the mass. Mass is already mentioned that we have to take equal mass. Mass can be different. The question might include that the mass is 4g, 6d. So there can be situations where the masses are different. But in this one, they have already mentioned that we are working with equal masses. So that's why I have selected mg. So I'm just equating the two equations now. And as you can see, we need to calculate the value for A, right? So we have way too many terms, and each and every single one of them has this m with them. So I can just factorize m from both sides of the equation and cancel it out. So you're left with half g plus A, and it's root over 3 by 2 g minus 1 by 4 g minus A. Okay, so if I shift A, so 2A, and then let me just solve the remaining values. Half minus root 3 by 2 plus 1 by 4. A equals 0.116g. I'm converting them into decimal since the question didn't say anything. You can keep the answers in terms of root. So it's 0.57. Let me check the answer first. Zero 0.569. Okay, so I rounded it up. If you want to take the answer in a 3 significant figure, but 3 decimal place, in that case 0.569. Okay, so this is the value for acceleration, and when you substitute this value of acceleration into this equation, the answer will be in terms of m.